2.5 Writing equations of lines and modeling. The purpose of this lesson is to try to come up with the equation that describe a line when we know some information about that line. For example, if we know 2 points on the line, can we come up with an equation? If we know the slope and a point, can we come up with an equation to describe that line? So the key terms we're going to need are point-slope form, slope-intercept form, and standard forms. These are three forms that describe a line, and we can use any form to write an equation. However, some form will be easier than the other. Point-slope form. So how did we derive at this form? Well, we began with the slope of a line, which can be written by y minus y1 over x minus x1, and that equals to the slope. The change in y over the change in x equals to the slope. What we're going to do next is we're going to multiply both sides by x minus x1. We're allowed to do that as long as we do it to both sides. This is one of the properties of an equation. These two, they'll cancel out, leaving us with y minus y1 equals to m times x minus x1. And this is what we call point-slope form. So when you see, and by the way, when you have an equation written in point-slope form, then the number in front of the parentheses, we call that m, that represent the slope of a line, and this x1 and y1, that is actually a point. So x1 comma y1. Looking at an equation written in point-slope form, can you tell me what the slope is? And can you tell me what a point on the graph is? So the slope is the number in front of the parentheses on the right side. Therefore, we're going to say that the slope is 1/2. And the point is going to be this x1 and y1. Now, one thing to keep in mind is there's a minus in front of the x1 and there's a minus in front of the y1, right? But when we extract that from the equation, we ignore the minus, okay? So in our case, the point is going to be 5 and 3. So 5 and 3. Find an equation of the line passing through 1, 4 with a slope of -7. So as you can see, I mentioned this at the beginning of the lesson. The whole purpose of this lesson is to take some information from a line and then write the equation to describe that line. Based on the given information, we have a slope of -7. So we know that our slope is -7. And we also have a point which the line happens to passes through. Okay? So we know what the slope is and we know what the point is. So the next thing we do is actually pretty simple. We take these two information and we plug them into the appropriate letters and we're done. So -7 is going to go into the place of m. Okay? This is your x1. That's your y1. So take these information, plug it into that form. We call this the point slope form. Okay, and you're done. So I'm gonna go ahead and write down the point slope form. Y minus 4 equals to -7 x minus 1. And we're done. This is the equation that they want us to come up with. So hopefully that's not too bad. Let's talk about a different form, okay? This second form is called the slope-intercept form. The slope-intercept form is the most commonly used form, especially when we're trying to simplify an equation. This form is helpful because it allows us to turn an equation into a function so that we can easily graph it, or we can easily interpret the input and the output. So the slope-intercept form. This is the form that we will use when asked to write an equation of a line. So there's another one. We use this form. So when do we use this form? We use this form when given the y-intercept and the slope. So the form is y equals to mx plus b. M is your slope and b is your y-intercept. This is an example of a slope-intercept form. By looking at the equation, we immediately know what the slope is because it is the number in front of the variable x. So it is 3. And we also know what the y-intercept is. The y-intercept is 0, 2. So that number tells us what the y-intercept is, which is kind of nice because by looking at the equation, we know where the graph is going to cross the x-axis, and we know the level of incline, which is 3 over 1. And that allows us to quickly graph the equation, or quickly taking this information and then turn it into an equation, right? We can take the slope and we can take the y-intercept and we can quickly turn it into an equation. So it's kind of nice. So let's go back to this form, slope-intercept form. Use it when you know the y-intercept and the slope. If you know the y-intercept and the slope, you can quickly write an equation by taking this information and plug it into this form. Alright, so here's your first challenge regarding the slope-intercept form. Find an equation of the line passing through 0, 2 with the slope of 3, which is kind of like the same as this equation, right? So looking at this problem, I know what my slope is, and I also know what the y-intercept is. If these are the information that I know, I'm going to use the slope-intercept form. So begin by writing down the slope-intercept form and then plug in the information accordingly. B is the y-intercept, and you're done. That's all you have to do. Standard form is the last form that describe an equation. Standard form is not commonly used to write an equation. There are times that you might ask to write it in standard form. It doesn't get used a lot in writing an equation to model a line, but it is handy to know for future references, such as when we get into solving system of equations. Let's do a few more practice problems on writing equation of a line given some information. There are times that you might be asked to find the equation that is parallel to another line, and that equation will pass through 1, -3. So keep this in mind. There are two things we need to find the equation of a line. We always need a slope and we always need a point, okay? So the first thing we have to do is we have to find the slope of the line we're looking for. Now, the fact that the line we're looking for is parallel to another line, it just basically implies that they have to have the same slope. So what we're going to do is we're going to try to find the slope of this other line and then use that as the slope of our current line. So the other line is written in standard form, what I'm going to do is I'm going to solve for y. I'm going to write it right in slope intercept form, or another way to think of it is to solve for y. So if I solve for y, I have to subtract 3x to both sides, and if I subtract the 3x to both sides, then this is what I'm going to get. And then I have to divide both sides by -1, and if I divide both sides by -1, so divide by -1, divide by -1, divide by -1. When you divide both sides by -1, you have to divide everything by -1. This becomes 3x minus 4. So the slope happens to be 3 because the slope is the number in front of x. I have found the slope. The second thing I'll need is I will always need a point when we write the equation of a line. So I have the two things that I need to write the equation of a line. Now I ask myself, which form am I going to use? Since I have the only time that you're going to use slope intercept form is when you have an intercept. Okay? When you have a y-intercept, that's the only time you're going to use slope intercept form. When you have the slope and a point, then use point slope form. Okay, write that down or keep that in mind. When you have the slope and a point, use point slope form. Use slope intercept form only when you have an intercept. So go back to this problem. We have a point and we also have a slope. So I need to pick the form I'm going to use. I'm going to use point slope form. And point slope form is y minus y1. Memorize these two forms or three forms and then plug them in. So I'm going to go ahead and plug them in. So y minus y, this is y1. So y minus -3 equals to 3, because that's my slope, x minus 1. Okay, y plus 3 equals to 3 times x minus 1. There you go. Now, generally, if they didn't ask you for anything further, like rewrite it in slope intercept form, then you can leave your answer as is. But there are times that you might have to simplify this a bit further by distributing and subtracting 3 to both sides and so on and so forth. But for now, you're done. You answer the question. You have written the equation of the line in the description. Find the equation of the line perpendicular to 3x minus 4y minus 3x minus y equals to 4, and the y-intercept is 0 and -3. So the first thing we need to do when we start out finding the equation is we need to find the slope. Find the slope. Find the slope of the line we're currently looking for. The line we're currently looking for is perpendicular to another line. So let me try to sketch an image for you. Maybe we are looking for this line. This is the line. This is the equation. This is the line referring to the equation we're looking for. We are given another line which happens to be perpendicular to our line. So this is helpful because the slope of our line is negative reciprocal of the slope of the line given to us. So the idea here is to find the slope of this line and then take the negative reciprocal, which is the slope of our line. We're going to go ahead and rewrite the equation. So rewrite in point, in slope, intercept form. Think of it as solving for y. So we need to subtract 3x to both sides. And then we divide both sides by -1 again. So y equals to 3x minus 4. Okay, so the slope is 3/1. Now this is the slope of the red line, which is 3/1. The slope of our line is negative reciprocal of that. So maybe I'll make a note. Our line, the line we're looking for, the slope is going to be negative reciprocal of it, because the fact that these lines are perpendicular. Okay, so maybe I'll put this in, I'll box this in red because it refers to the line, to the other line. Awesome, we have the slope. We're going to go ahead and find the point, but the point happens to be the y-intercept. So this makes our job pretty easy. What we're going to do is, because we're given the y-intercept and the slope, we're going to use, we are given the y-intercept and the slope. We're going to use slope-intercept form, which is this form. So the slope intercept form, y equals to mx plus b. Go ahead and plug in your slope. Go ahead and plug in your y-intercept, and you're done. All right, a couple more challenges. Write an equation of a line containing 2 points. So here it is, guys. The line we're looking for is going to go past these 2 points, and they want us to write an equation to describe that line. So we always start with the basic form. Find the slope. Okay, find the slope. Or what is the slope? Now, depending on the situation, the way how to find the slope will vary depending on what's given. Because we're given 2 points to find the slope, we're going to use the slope formula for 2 points. Remember this formula? Go ahead and plug in the numbers accordingly. y1, y2. Okay? y1 minus y2, x1, x2. So x1 minus x2. So what do we have here? We have m, which is the slope. It's going to be 18. This equals to 18. We have to add. This equals to 6. And that simplifies to 3. Our slope is 3. All right, so we have a slope. We either need the y-intercept or we need a point. In our case, we have 2 points to work with. So pick one of these 2 points as your key point. I'm going to pick the first ordered pair, which is 2, 14. So now I have 2 information that I need in order to write the equation of a line. I have a point, slope. So I know a point, slope. Therefore, I'm going to use point slope form. Okay? So point slope form. Y minus y1 equals to m times x minus x1. We now plug in the information. So y minus 14, because y1's 14, equals to, your slope is 3, and then x minus your x1 is 2. And you're done. Alright, let's take a look at a simple application. It's not going to be too hard, so don't worry too much. Modeling. So in 2005, Americans recycled 79.9 million tons of solid waste. In 2010, the figure grew to 85 million tons. So let N represent the number of tons in recycled in millions, and T the number of years since 2000. Find a linear function that fits the data. So perhaps before we continue further, let's take a look at a couple information that's useful. So in 2005, 79.9 million tons were recycled. In 2010, 85 million tons were recycled. So as you can see, if we just kind of sketch the graph to represent the data, we can probably see that if this was 2005 and this is 2010, then the number of recycled has gone up, right? The data has gone up. Okay, so the question here is, the part A asks us to write a function, an equation that models this line. Okay, so what we're gonna have to do, or what we need to do, is we need to kind of do what we did here. We need to find the slope of this line. We need to find a point, and then put it together. The cool thing here is the two highlighted information. You will know what it does. It gives us 2 points. Okay, so I use 5 for 2005, and I'm going to use 10 for 2010. The fact that we have 2 points, we will now find the slope of these 2 points. So let's go ahead and write slope. And to find the slope, we take the change in the y's. So that's 79.9, that's the first y, that's the second y, minus 85. Divide that by the change in the x, which are 5 minus 10. 5 minus 10. So I am going to use a calculator to assist me in finding the slope. So 79.9 take away 85, that gives me negative 5.1, and then 5 take away 10 is negative 5. So I'm taking the top number and I'm dividing it by negative 5. So the slope comes out to be 1.02. 1.02. 1.02. This is your m, okay? This is your m. So we have the slope. We also have a point. We have a point. Let's use this point because it's without a decimal, so it's nicer. So I use that point, and now I'm going to write the equation. So remember that I need to use point slope form. So that's y minus y1 equals to m times x minus x1. Y minus y1 is 85. 85 equals to m is 1.02. 1.02. And then x minus x1. Okay? So find a linear function that fits the data. So this is an equation. We're going to go ahead and distribute this equation and then turn it into a function. What we need to do next is we're going to distribute 1.02 to x and 1.02 to 10, and then add 85 to both sides. So I'm going to take some room over here. If I take 1.02 times x, I get 1.02x. And then if I take 1.02 times 10, then I get 10.2. I need to now add 85 to both sides. So y equals to 1.02x. And then remember, I'm adding 85 to both sides. So I'm going to take 85 and then I'm going to minus 10.2. Brings me to 74.8. And that's my function. So here's the function. So this is the function that model the growth of solid waste, American recycled, with the data that we're given. So we completed part A, we find a linear function. Part B, use the function in part A, this is the function in part A, to predict the amount recycled in 2016. Okay, so remember that if x represent 0, if x equals to 0, then it means 2000, right? If x equals to 5, then it means 2005. If x equals to 10, then it means 2010. So in 2016, it implies that x equals to 16. So part B, we take this function, and to make the prediction, we will now replace x by 16 and then add that to 74.8. So 1.02 times 16 plus 74.8, that gives us over 91 million tons of solid waste. So it equals to f of 16 equals to 91.12 tons of solid waste. So to answer part B, we would say that the predicted amount that will be recycled in 2016 would be 91.12 million tons of solid waste.